All right, guys. So this is going to be our project due Friday, beginning of class. So it's going to give you the rest of class time to work on it today, all of class tomorrow. Now, what you're going to wind up doing is out of the 5 reactions, you're going to be given 4 of them and be asked to come up with like a cartoon version of each equation. So let's zoom in so we can see this a little bit better. All right. So you're going to create an illustration / cartoon. All right. Example of each of these 4 reactions listed below, not included, all right, was the combustion reaction. Now, they're not to just be, the drawings are not to be just real chemical reactions. They're not supposed to be just like like mix, this in a beaker and this, and I got this solution or whatever. No. I want it to be something easier to be understood. So we're going to look at a couple examples in a minute. They need to make sure that they have the major characters of these type of reactions. You'll then also need to write, all right, the equation's basic form, which is listed below here in bold. So each of these bold, all right, basic letters here, this is the basic version of it. After you then have completed it, you will then need to have an actual balanced chemical equation that goes with that type of reaction. Okay, they explain what synthesis, decomp, a single replacement, and double replacement is. We dealt with that with the Shall You Dance, all right, little activity there. So let's just kind of look at some of the examples. Here, I have a synthesis reaction. Someone's kind of showing it. What are these? Chuck Taylors, all right, Converse, little like mid-top with 4 wheels, and what gets kicked out, we get a rollerblade. A synthesis reaction. So you have like basically 2 elements, 2 simpler things that combine into one compound or a more complex thing. Decomposition. You're starting with something that's a little more complex, and it breaks down into its basically smaller components, simpler components. So here we would basically have like a turtle in an egg. So you could kind of like, if you were doing that, let's say as an example, you draw a little egg with a little crack in it. You maybe show an eye on the inside. You could do a little word bubble saying, Mister, get me out of here. Decomposition, right? And we have like the broken eggshell that he came out of, and then your turtle or reptilian. I don't know what other animals come out of eggs like that, but whatever. Dinosaur, cool. Single replacement, all right? Guy, girl, yellow thing. Yes, I know what they are. I'm not saying their names, all right? So in this is a single replacement. So you have your one compound, 2 things together, and then another element by itself. That element is going to replace one of the other 2. So over here, yellow guy and the dude, and then now the girl is chilling by herself. So yellow dude replace girl. So on this side, these 2 are now together, and girl chilling by herself. Double replacement reaction. Technically, it's when 2 cations swap. 2 cations swap. In which case, if we're looking at it like this, right, you have a plus, minus, plus, minus. So Luigi should be the plus. He's going to switch with Peach, all right, the chick in the pink. So you would have green and Daisy, green and yellow, and then you would have pink if she's the cat eye in here, pink and red. She should be like in the opposite order. She should be technically ahead, or flip-flopped. All right, so it should be like plus, minus, and then on the other side, different. The 2 pluses would switch sides. Okay, here's a real example. One of my former students, Kyle Lorenzo, put up.
Excuse me, may I have Brianna Meyer, please, to the main office for early dismissal?
Sure.
Thank you.
Oh, that is so annoying. All right. Well, let's continue. Nope. All right, so here they're showing a synthesis reaction. So they clearly label the synthesis reaction. They have drawn 2 of their cartoon things, okay, from simpler parts into the more complex. Let's zoom in a little bit more. All right, in this one, they're showing a single replacement. You have regular Batman, Batman Beyond, plus the Joker card here. Swaps it out, and we have Batman and Joker, and then Batman Beyond is getting the boot. So they label it single replacement. Now, there's one thing missing that I will kind of show in my little example. And then what is good here is they have a balanced chemical reaction of that type. All right, this is a single replacement reaction, and it is balanced as is. Then they show over here a double replacement reaction. Now, technically, cations should switch. So cations would be, all right, guy comes first, all right, so it'd be positive ion, negative ion, positive ion, negative ion. The two positives should swap, but this was amazingly, this is really great artwork, so it's still a great example. All right, you got, I don't know, regular Spider-Man, Miles Morales, you got Noir, you got Gwen. All right, technically speaking, this dude should be swapped out over here, so this guy, Noir, should be with Miles, but they have opposite, but I mean, again, still amazing drawing, still good visual representation. That they have now switched partners. Double replacement reaction, and here, right there, they have it listed as, all right, a balanced chemical equation for a double replacement reaction. And finally, all right, this example that they drew was a decomposition reaction. You had a more complex thing, the Hulk, all right, when it breaks down into its simpler parts, it was due to the gamma radiation and Bruce Banner. So, again, he has the balanced chemical equation there. So, let's see, how do I want to say this? So, we're going to be doing this, and we're going to be going through it with, all right, you're going to be doing drawings. Now, you have two options. You can draw these out on your own. Okay, you could look up something and trace it, or if you can print something out, you can trace it, but you cannot just print something out per se with print it in color and just slap it on. So drawing is one option. And then another option I discussed with my classes, all right, and we kind of settled on if we wanted to do that, was that you could, for example, look up whatever is in your idea wheelhouse, okay, and then type in coloring pages, all right? So something cartoon and then coloring pages. So what I would allow, all right, granted everyone's not the greatest drawer or artiste, but let's say my example was, okay, I decided to show a synthesis reaction. So I was like, all right, let me look up ideas. My idea was, let me take Baby Yoda by himself, Mandalorian by himself, and then show them together. So A, one individual, B, the second individual, all right, goes through the reaction, and they come out together as a pair. So I show the type of reaction, the individual parts with the pictures, and then the compound or the two pictures kind of together in some form. The base equation, which was highlighted on all of the spots in the cartoon, all right, these bold lines, these bold dudes, and then afterwards a balanced chemical equation. So if you're not sure what a balanced synthesis equation looks like, you can literally Google balanced synthesis equation example, and you should be able to find ones. All right. So that would be an example. So you can't just look this up, do it on a Google Doc, and then print it out, and then just cut it all out like that. No. Okay. If you're going to do something like this, if you're not going to draw or do the trace, if you're going to, all right, you can freehand if you want. So it's freehand, it's trace over something, or, all right, you come up with your pairing that you're going to wind up using. You can print out a coloring page of whatever it is. You can print that out at home, or you will have to find time after school possibly to go to the media center to print them out. Print it out. All right, you can color it. Make sure it's not super, super big, because the piece of paper, the final part, what it's going to be on, the size of the paper is like this. I'm going to show it here in a second. It's about yay big. So okay, so this is like the size of the paper. And this is like a regular piece of computer paper. So it's, if you decide to do the coloring pages, okay, you want to kind of fit it so you'll have space to do the 4 of them. All right, the final project, the final part will all be on one big piece. You can kind of divide them up into their little sections. Kind of like Kyle showed in this one, he broke it down. So he's got the synthesis reaction in one area. He's got the decomposition. He's got single replacement, double replacement. All right, has the idea of, he put cartoon chemistry reaction types. Definitely color. Okay, he's got the reactions in there. So the only thing that's missing from this that I want you guys to make sure is, okay, obviously label what type of reaction, your parts to it, and base equation like this, and then you would find a balanced equation. Okay, you can look it up online to figure that out if you need, and write one in. So you can trace, look at an object or look at some things, get your ideas freehand. All right. I would suggest doing like rough copy first before you try and put everything on one perfected giant piece, because you may start somewhere and realize, oh crap, now I don't have enough room for everything, and then it gets tight and kind of squished. So I would suggest maybe starting out on like a, okay, here's like a little one that I just kind of made during my one class, a vague idea of what I was showing. Okay, you got Baby Yoda chilling by himself, you got Mando, and then the 2 of them together. All right, you have your A plus B yields AB. Underneath that, you're find a fully balanced synthesis reaction equation, and above somewhere, okay, you write what the type of reaction is: synthesis, decomposition, single replacement, double replacement. We're only doing those 4. We're not doing combustion. So I posted this on Google Classroom so you guys can get Chromebooks. You'll be able to kind of Google and look up some ideas. Someone came up with an idea that was kind of cool. You can do it cartoon-based, show-based that you like, sport-based, food-based. Someone showed like a pretzel and then like a chocolate bar, and then it reacted, or it synthesized into a chocolate-covered pretzel. Kind of a cool, all right, nice little originality piece to it. And also attached to this on Google Classroom, I have a rubric that goes along with it. So to get 100, you want to make sure you're in the excellent range for all this. Now, it does say here, okay, that speech bubbles are clearly neat and legible. You don't necessarily need speech bubbles, but if you want to add to it to make it something a little humorous, all right, that is fine. That would work. Okay, and kind of go through it. So again, for chocolate reactions, you make sure that you have the type, all right, your pictures that go along with it that explain the base equation, and then a balanced chemical equation for each of the 4. Okay, you can freehand draw it, you can trace it, you can print something out and trace it, or you can print out a colored, all right, a coloring page. Don't just print out like an actual something like this. Okay, I don't want you printing like this out that's already whatever, and then you cut this out and paste it. That not okay. All right, that's too easy. Okay, print one of these guys out. Make sure you size it correctly so you'll have enough room on the big sheet of paper to make sure everything fits. And you would cut it. Make sure you color it, cut it out, then you can put it on there. So again, we'll have the rest of today to come up with your ideas. I would maybe suggest starting a Google Doc to kind of just get your ideas going on what you think you're going to want to do. And then you, on a separate sheet of computer paper, you can start doing little rough copies and hold it up next to the bigger piece, so you can kind of figure out like the amount of room that it's going to take up, right? So if this is essentially how much room I used just for this one, all right. Okay, so I'll have some here. I'll have, synthesis. I'll have like some place in the middle or on the top where I want to like give the title. Okay, cartoon chemistry of chemical reaction types, something along those. Yes, you can have like something, lines that are kind of nice, fancy-ish, that will kind of separate everything. Okay, again, here's some kind of stuff going on. All right, but don't want there to be a lot of like completely wasted space. And again, wasted space doesn't mean like just like a bunch of blank white spacing going on in this. Okay, like something goofy for the Spider-Man thing, right? He has like a little spider web here. He could have had another little spider web somewhere else. He's got the spider dangling on the string in the Batman one. Maybe in the background, something silly or easy. You could draw a little bat. Hulk, all right? They added little atoms here. For the Optimus Prime, I guess this is supposed to be like little sound waves of him transforming. And we got these lines in the back, which I'm guessing, not 100% sure what this was. I can't remember what he said it was for, but looks like maybe it's like shattering through glass or something along those lines. Okay, the Hulk, you got the ground breaking here, you got a little So very, very well done. Okay, this is obviously a super, super, very great drawing. If you're not the greatest artiste, again, don't have to freehand if you don't want. You can trace, all right, or you can print out a coloring page and color, cut, and put it down on the final copy. Okay, got it. Everybody got what we need to do. Okay.